Hey everyone, I'm going to quickly go over the answers to the homework since we didn't get time to do it in class. All right, so our first one, we have two functional groups, a ketone and an ester. An ester is all the way at the top of that oxidation ladder and can only be reduced by the most powerful reducing agents. So if we want to reduce both of those functional groups, we're going to need to use lithium aluminum hydride, followed by H2O and an acid. All right. If we only want to oxidize one of the functional groups while leaving the ester intact, we could use the weaker reducing agent NaBH4, sodium borohydride. All right. One thing to note, when we reduce an ester, we are cleaving that ester, that CO bond in the ester. So we do reduce the number of carbon in this molecule and release that CH3, becomes CH3OH. Okay, so it's getting reduced as well. Right, and again, that's coming from the CH3 that's sort of getting chopped off of that molecule. Okay, looking down below, here we have got two carboxylic acids that we want to oxidize into alcohols, and they'll become primary alcohols. So again, that's at the top of the oxidation ladder. We're going to need to use LAH for this one. Again, followed by water and H2O. If we wanted to do the reverse, to oxidize primary alcohols all the way back to carboxylic acids, we would use a strong oxidizing agent, such as our sodium Na2, CrO4 with acid, or KMNO4 with a base. Okay? Both of those are very strong oxidizing agents and could reverse that. Okay. Here we have our alcohols becoming aldehydes. Okay, so if we want to oxidize an alcohol to an aldehyde, but not all the way to a carboxylic acid, we're going to use PCC, which is not strong enough to oxidize to a carboxylic acid. Reducing aldehydes to alcohols, we could use any of our reducing agents, NaBH4 or LAH. Generally, if given the choice between the two, we should use the less caustic or less reactive of the two, NaBH4. Again, like I said, LAH is very reactive, and it's really not great to use if you can avoid it. Okay, last one, fun. We've got a ring with another ring kind of attached in a bridge formation. Now we're reacting PCC with it. Remember, PCC takes primary alcohols to aldehydes and secondary alcohols to ketones. Okay, it cannot react with tertiary or quaternary carbon because they don't have enough hydrogen bonded to them. So let's see what we got here. In this molecule, we have that's a primary alcohol. So this is going to become an aldehyde. Okay. Actually, I'll just draw that. Become an aldehyde. Here, we have a secondary. That's going to become a ketone. And up here, we've got a tertiary alcohol. That's going to do nothing. Okay, so gonna have fun trying to sketch this molecule on your own. It's one of the best parts of organic chemistry is you do get to draw a lot. Okay, so here's our molecule. This is going to become an aldehyde. And here's going to be our ketone. Up top, it's going to be unchanged. Okay, great. If you have any questions, please let me know. Have a good one.